Hello and welcome to the walkthrough video of the advanced project topic, Scalable Deployment using Docker. This video provides a brief information about Docker and how does it works and its usage, followed by the small tutorial about how to develop and deploy an application with the help of Docker. To get much more deeper understanding about Docker and scalable deployment, please see the following attached document. Let us understand, first of all, what do you mean by scalable deployment and what is Docker? Increase or decrease in performance and in cost, response to changes in application and system processing demands is what a scalable deployment means. Example, and Docker is used to facilitate the scalable deployment. Now, let's take this concept of containerization to the world of software development. So, as you can see in the diagram, Docker enable us to run each component in separate container with its own dependencies and its own libraries, all on the same virtual machine and the operating system. But within separate environment or container, you just have to build the Docker configuration once, and all the developers could get started with the simple doc run command, irrespective of what underlying OS they are on. Okay then, let us now understand the main difference between containers and virtual machine. Traditionally, virtual machines are used to avoid unexpected behaviors. The main problem with virtual machine is that an extra OS on the top of the host operating system adds gigabytes of space to the project. Most of the time, your server will host several virtual machines that will take up even more space. And by the way, at the moment, most cloud-based service providers will charge you for the extra space. Another significant drawback of virtual machine is a slow boot. Docker eliminates all the above by simply sharing the OS kernel across the containers running as separate processes of the host OS. Keep in mind that the Docker is not the first and not the only containerization platform. However, at the moment, Docker is the biggest and the most powerful player on the market.
Now let's begin with the fundamentals of Docker. Let's start with the architecture. So Docker is based on a client-server model, which means there will be a client CLI which takes in the commands, and a server, which is usually a daemon that is running in the background that actually is responsible for creating the images or running the containers. Now it's not necessary that the client and the server should be present on the same host, but you can use the client to connect to any server located elsewhere. So images are templates using which we can create containers. So essentially images have to contain all the details about the environment, the libraries, the dependencies that our applications would require to be up and running. Now the beauty of images is that I can build upon images using other images. So I can use the base image of a Node.js or Linux environment and add my own libraries onto it, and I can just create an image out of that. So if my application requires those libraries, I just have to use the same image every time. Now images are not the things that are running. The containers use the images to run the applications. So containers are your applications. Whenever you ask Docker to run an image, it makes a container using that image and runs your application in it. These containers are kind of isolated, which means they cannot access the file system or the network unless you specify them to do it. So the Docker file is the only thing that is required by Docker to create an image of your application. Like you can see here, this is an example Docker file. It just contains a set of instructions that is executed by Docker to create your image. Now coming to Docker Compose, since usually we have multiple containers to run an application like front-end, back-end, database, we can't be starting each one of them every time, since as the number of containers increase, it will take even more time to start them one by one. So what Docker does is gives us a compose functionality, which means we can start all of our containers at once. So all we have to do is make a docker compose.yaml file, which kind of looks like this, in which we can mention all of our services or containers that we have to run, and it will just start all of them at once. We can even mention the ports, the networks that they are in, and it will take care of everything.
So we have created a sample demo application to demonstrate the usage of Docker container. This is the application we built. Basically, anyone can go and vote for the team they support. So we have used 3 different technologies in this application. For backend, we are using Node.js. For frontend, we are using React.js. And to store the vote count, we are using Redis. First, let's go through the Docker file of our Node.js. It's a pretty simple Docker file. Basically, starts from scratch Node 16, copies the packages onto our container storage and runs installation and just starts our service. Similarly, same is the case for frontend as well. For Redis, we don't need to have a different Docker file. We can just use it in a Docker Compose file. So this is our Compose file. As you can see in the services, we have 3 services: frontend, backend, and Redis. So our backend depends on Redis ABC. This is very important to mention this. Otherwise, the connectivity between our backend and Redis won't work. This is the port that we are exposing to our localhost, and same is for frontend. So let's see. I'll just close this and run it again. let's see how this. So this is the command you have to run to make a build of the entire applications. As you can see, it has started with it created the project for Redis. This thing basically it created a custom image and started a container with that. Localhost 3000. Yep. So as you can see, initially the word count is 0 because we are storing the data in our Redis database, and it resets as soon as you restart the server. So it is not persistent yet, but this application, the purpose of this application was to just demonstrate using different technologies together and how Docker Compose helps us to compose all the containers together, and you can just run your server in with one single command.